Hi everybody. This tutorial is about tying up some loose ends with vectors. That's why I call it miscellaneous vectors. It wasn't important for the projectile motion where we took a vector and broke into components. This is going to be important for the next unit where we start focusing on forces. So I'm going to work through some problems for you. I'm going to leave the rest for you to do on your own, and then you can ask questions in class. Some of it you learned in the previous tutorials on vectors, especially subtraction, but I haven't done anything with it since, and I'm saying to myself, oh yeah, you really should know this, especially for some upcoming stuff. All right, so let's start with problem one. We've got two generic vectors, okay? One is 5 units long, the other is 20. This could be a displacement, it could be a force, it could be acceleration or velocity. And they're pointing in any random direction. I've drawn them the way they are, but they don't have to be pointed that way. They're just two vectors. So some questions we can ask about them are, what are the extremes? What's the maximum they could possibly add up to? What's the minimum? And then could they add up to something else? Stuff we've kind of talked around. You probably understand this, but I want to make sure we can look at it from different angles, so to speak. So the maximum magnitude would add up to 20 plus 5. Okay, so I think we recognize they could add up to 25, but then we can ask what angle would they have to be oriented relative to each other such they add up to 25. Conceptually, I'm guessing you understand they'd have to be pointing in the same direction, right? The 5 would be pointing one way, the 20 would be pointing the same way. It doesn't matter whether it's to the right or they're both up, but they're pointing in the same direction. So what's the angle between them? It's not obvious the way I've drawn them, but you look at their parallel. When they're parallel, they're 0 degrees. In other words, there's no angle between them. Another way I could draw it is I could draw the 5, the beginning of the 5, right? Here's the 5, and then I add the 20 to it, and the angle between the green and the red is still 0. There is no angle. So you want to understand that part. Then we could ask, what's the minimum they could add up to? So the minimum is when they're in opposite directions. So one would be 20. The other would be -5, or you could say negative or positive 5, -20, but the magnitude, I don't put a negative in there, would have to be 15. So that would be if one is pointing this way and the other is pointing the opposite way, or I could draw the other one that way. It doesn't really matter. Key question though, what angle is between them? It's not going to be 0 because 0 gives us a maximum. So so if I draw the 5 like that and then put the 20 on top of it like that, the angle between them, because they're anti-parallel, opposite directions, is 180 degrees. So what that means is the extremes that they can add up to are anywhere from 15 to 20. So if the sum, right, I'm just going to put the sum of the vectors, of the v's, okay, if it's a maximum, the angle is 0 degrees. If it's a minimum, the angle is 180. So what if it's somewhere between those two? Let's say 90 degrees. Well, then it would make sense that the sum is going to be somewhere between 15 and 25. What exactly it is? Well, you do the Pythagorean theorem in that case. If it was 60 degrees, it would be closer to 0 than it would be to 180. Well, kind of. I mean, it's not necessarily linear. It doesn't fall off linearly with distance or with the angle, but you get the idea. So you can also estimate what the sum will be based on the extremes. So the next question is, could they ever add up to 22 units? Well, if the minimum is 15 and the maximum is 25, then the answer is yes, they could. They would just have to be oriented at some angle. So sketch how they have to be oriented to do that. You don't have to do exact triangles of the trigonometry. And based on what I was just saying, we can say, all right, 25 is when they're in the same direction exactly. 22 is kind of close to 25. So one of them, let's just draw it horizontal just for ease sake. Let's call it the 20. I'm going to add to that the 5. Well, I don't want to draw the 5 like that because that would give me 25. So I'm going to angle it up a little bit or down such that it's maybe something like that. So that would be the 5. And we can kind of see that it's still pretty long, and there's going to be some upward part to that. And then we can convince ourselves that could be close to 22. As opposed, if I were to draw a 5 like this, 90 degrees to it, well, that's going to be 20 squared plus 5 squared, which is close to 20. So it's going to be, that wouldn't be too far from 22, but you get hopefully the idea. Next question. Could they ever add up to a magnitude of 12? Well, again, if we look at the extremes, 12 falls outside of those extremes, so the answer is no. Okay, because that's less than the minimum value or minimum possibility. So you want to be able to answer questions of that nature. So try practice 1 and 2, and the answers are off to the right. And if you have questions on that, then by all means ask. So let's turn to the next page. Going back to subtracting vectors. You have a tutorial where you learn how to subtract vectors. It's the same note sheet where you learned how to add vectors using Pythagorean theorem. Actually, it's even before that, when we first introduced vectors in the tip-to-tail method or the parallelogram method. So it's important for you to review that, but I will go over the basics. Subtracting vectors is essentially adding vectors. You just got to do one intermediary step. So in all these problems, A, B, and C, I want you to take vector y and subtract from it vector x. So in order to do this, we want to make this an addition problem. I'm going to say that time and time again. So if you ask me, how do you do this? Did you make it an addition problem? How do we make a subtraction problem an addition problem? Well, we just use plus and negative. So y minus x is equivalent to y plus a negative x. There, I've made it an addition problem. So all I've got to do to find this is to do this. I've got to add y and negative x. Well, here are the two vectors in question for A. So there's y, there's x. I don't want x, I want negative x. So I'm going to, so negative x, I'm just going to draw off to the side just to make sure clear, is the exact same thing as x, just pointing in the opposite direction. So I'm going to pick up this vector and put it, so I'm going to ignore this now because I've already transformed it into this, and I'm going to put this vector at the end of y, right? Here's y, here's the beginning of y. Now I'm going to pick up negative x and put it at the tip to tail. So there's negative x. And so I want the sum of them, right? The plus. So the sum, that's the resultant. So there's the beginning of y. Here is the end of negative x. So there is y minus x. That's all you have to do. Is again, transform the negative value to a plus and then flip it around on the sketch and put it tip to tail to the one you're subtracting it from or adding it from. So let's look at this one. We got y and x. They're tip to tip, but that doesn't matter. I'm going to maybe off to the side. You don't have to do this, but I'm trying to make it clear for you. So I want to do this as y plus negative x, as always. So if this vector is x, then this vector is negative x. So I'm going to pick up negative x and put it at the end of y, okay? Actually, if I do that, I would just have this. That's nothing wrong with that, but it might be confusing you because I'm drawing it over the old x vector. So I'm going to do something else. I'm going to put the end of x at the beginning of y rather than the beginning of x at the end of y. So I'm going to put, here's negative x. I'm still pointing to the left. So here's the beginning of negative x. Here's the end of y. So negative x plus y is the same as y plus negative x. I don't want that to confuse you. So my difference is going to be pointing that way, the beginning of this to the end of that. If I had done what I originally did, if I put negative x there, then I would go from here to here, and notice these two are pointing their exact same vectors. They're in different locations, but that doesn't matter. What matters is the length is the same and they're pointing in the same direction. Last one is we have, actually I want you to do this on your own. So I want you to try C on your own, and then I want you to do number 4. Okay, number 4 is trying to anticipate some physics we're going to be doing later on, but it's the same thing. You're just basically doing y minus x. So good luck. We'll check these, or if I have you upload these, I'll check them, and then we can ask questions in class.